Thank you for that introduction. Hi, everybody. My name is Zuri. As Becky mentioned, I'm a graduate student in the Department of Amino Biology at Yale. And the title of my talk today is I Believe I Can Fly, How Bats Can Teach Us About Fighting Ebola. So I first want to just start off by introducing what Ebola is. It's caused by a virus, and we hear the word virus a lot in the news, but I just want to take a second and explain what a virus actually is. So the most basic definition of a virus is that it's genetic material wrapped in protein. And so what I mean by genetic material is the information that tells an organism how all the instructions for life. So in humans, our genetic material is encoded by DNA, and viruses can use DNA as well, but Ebola happens to use a related molecule called RNA. And so this is just a general picture of a virus, and you can see the genetic material here in the middle in white, and then surrounding that is the protein that forms the capsid of the virus. So second really important fact about viruses that help us understand how they cause disease is that they all rely on a host cell for survival. So strictly speaking, viruses aren't considered to be alive. Instead, in order to make more copies of themselves, they rely on hijacking the machinery of a cell that they infect. And you can see that here, where the big thing here is actually one human immune cell. And all these tiny buds you see on the surface are HIV virus particles budding out from inside that cell. So they've gone into the cell, they've made tons of copies of themselves, and then they're budding out and they're going to go and infect other cells. And then the last fact I want to bring up that's a little bit more particular to Ebola virus is that viruses can be zoonotic, and that means that they can infect more than one kind of host. And so zoonosis as a phenomenon is the idea that when infections can spread from animals to humans. And there are a lot of examples of this that you may be more familiar with. So there's bird flu, which can spread from birds to humans. There's HIV, which is thought to have originally spread from monkeys to humans. There's mad cow disease, which spreads from cows to humans. There's the plague, which spreads from rats to humans. And there's Ebola, which we're talking about today, that's spread from bats to humans. But something really interesting about bats that get infected with Ebola and then transmit to humans is that there's actually no evidence that bats get sick when they get infected with Ebola. And so in that respect, bats are what we call a reservoir, which when we think about reservoirs in our everyday language, it's where we store water in case we need some more at some point. And so with respect to viruses, a reservoir is where nature can store them. And so bats are an example of a reservoir for Ebola, and they're actually a reservoir for a lot of other really dangerous viruses. And so I'm going to come back to some of the reasons why that might be. But I first just want to talk about when Ebola infects humans, because as we know, humans get really sick when they get infected with Ebola. So here are just the symptoms of Ebola. The full name is Ebola hemorrhagic fever, and the word hemorrhagic means that it's characterized by extensive bleeding. And so you can see that here where this guy is bleeding out of his eye, he's got a nosebleed. People who get infected with Ebola often have vomiting and diarrhea with blood. They also have a characteristic skin rash, about 50% of people. Then they also have muscle and joint pain and fever, which if anyone has had the flu or something like that, you know are symptoms of other infections that aren't as concerning as Ebola. And so that's why it's really important that there are specific lab tests that diagnose Ebola and distinguish it from these other diseases that cause flu-like symptoms. So a few other facts about Ebola, 50 to 90% of people who get infected die, so it's a really dangerous public health concern. But people who seek treatment early have a better chance of survival. And currently, the only approved treatment in humans is rehydration and managing symptoms. There is an experimental treatment called ZMapp that you may have heard about that's been shown to be effective in monkeys and has been tested in some people, but currently it's not, strictly speaking, approved for use in humans. There's something that Kyla will talk about more called the incubation period for Ebola. That's just the period from when you get exposed to when you start to show symptoms. And so that's 2 to 21 days for this virus. And that incubation period is important because people are only contagious once they start to show symptoms. And so you may have heard in the news people being quarantined for 21 days, waiting to see if they would show symptoms, and that's because of this incubation period. So I'm an immunobiologist, and I study how our bodies interact with these infections. And when you get infected, your body's reaction to it is just as important in determining whether you get sick as the infection itself. So I just want to quickly go through the steps of an immune response to Ebola to try and illustrate this. So the first step in an immune response is recognition. Your body can't mount a response against something unless it knows it's been infected. And so how that works is that, say you get exposed to Ebola, you have the virus over here and an immune cell over here. And if you could zoom in on this interface between the host cell and the virus, you would see that our immune cells have special molecules on their surfaces and inside that can recognize foreign invaders. So they can recognize things about the virus that are different from humans. And when they do this, they start the second part of the immune response, which is what immunologists call an effector response. And that's sort of where the action is. That's where your body starts trying to kill off this virus. And so what happens is this blue cell, which is the same as the orange cell that I showed in the previous slide, recognize it's been infected and then can go and tell special killer cells called killer T cells that there's been an infection and educate the T cells on how they can go out back into the body and find the Ebola infected cells and kill them. And the way that T cells do this is by shooting out a lot of these really nasty molecules that kill the infected cell, but they also can kill some of the surrounding cells. And that's okay because it's a trade-off between killing infected cells versus a couple of surrounding cells. But this is only okay when you have the third step of the immune response, which is called contraction and memory. And so after enough of the infected cells have been killed, the immune response needs to be dampened down in order to avoid damaging the rest of the body, because an immune response that's out of control can actually be really dangerous. And memory is also a really important component of our mammalian immune response. So once we've been exposed to something once, when we get challenged with it again, our immune system remembers and can do this whole immune response a lot more quickly. And so that's the basis of vaccination, where rather than actually having to be infected with something and get sick, you generate this memory just by a vaccine. But in Ebola, this contraction phase doesn't work very well. And as I mentioned before, that's a problem because this effector arm of the immune response can cause a lot of damage to the surrounding tissue. So when you get infected with Ebola, the immune response is trying to fight it off, but the virus sticks around, and you get damage to the surrounding tissue that results in something called amino pathology. So this is an unintended consequence of an immune response, and it happens because, as I said, the infectious agent fails to be cleared by the immune system, and you get this resulting damage to the host tissue. And so that's what happens in Ebola. So when you get sick from Ebola, what actually causes all those symptoms on the slide that I showed a couple of minutes ago isn't the virus itself, but it's the cause of an unchecked immune response that fails to be dampened. And so the reason that we have immunopathology, and maybe that other organisms don't, is that we have actually three modes of defending ourselves. So you can think of an infection as a problem, and you can deal with the problem by either eliminating it or dealing with it. So if my problem is that I don't have any clothes to wear because they're all dirty, I can eliminate the problem by washing my clothes, or if I'm lazy, I can adapt to the problem by just buying new clothes. And so the immune system kind of works in the same way. So you can think of an example from plant biology where this idea has been really well described. You might have this blue plant virus over here, and if your plant's susceptible to it, it's going to wilt and look sad, and it's going to have all of these blue virus particles all over its body. But if it's resistant and its immune system manages to clear this blue virus, it's not going to have any of it on its body. It has these big oranges, and it's standing up tall, and it's doing fine. But what can also happen, if rather than eliminating the problem, it adapts to it, it can be what we call tolerant. And so here you have this blue virus that's all over the plant, but it's standing up and looking healthy. And so rather than trying to eliminate this virus, the plant's just decided it's going to deal with the effects of having it around and stay healthy. And so that's what scientists think might be going on with bats when they get infected with Ebola, because as I mentioned before, bats get infected with Ebola, but they don't get sick like humans. And so there are a lot of ideas that scientists are thinking about about why this might be. And so I just want to draw some important comparisons between bats and humans that might help explain why bats are more tolerant to Ebola. So first of all, bats and humans actually have really similar immune systems. We're both mammals, and so for the most part, their immune response follows the same rules that I outlined in a couple of slides ago. They recognize the infection, they mount an effector response, and then they have contraction and memory. But unlike humans, bats can fly, and so you might not think that relates to the immune response, but one idea is that when bats are flying, it's kind of like they're constantly exercising. Their cells have a really high metabolism when they're in flight, similar to a human when we're going to the gym. But this high metabolic rate can be really stressful for the cells. And so one idea is that because bats have evolved to fly, their cells may have evolved ways of dealing with this stress that's caused by this elevated metabolism. And perhaps some of these stress management strategies could help the bats be more tolerant to an Ebola infection. Another difference between bats and humans is that bats, a lot of them hibernate and humans don't. And so this kind of plays into this idea that they manage stress better. So perhaps when they hibernate, their cells are repairing themselves, everything's kind of slowed down, sort of an idea of what happens to us when we're sleeping, but hibernation is a much more extreme state than sleep. So maybe they have more repair going on in their bodies when they're hibernating. And then when they're hibernating, there's perhaps the virus is replicating less, the immune response is a little more slowed down, and so they're less likely to have this immunopathology. And then the last important difference between bats and humans is that bats have a much higher body temperature than humans. So when they're in flight, their body temperature can be above 104 degrees Fahrenheit, which for us is a pretty serious fever. As you can see here, if you had a temperature of 104, you would be sick in bed. And so why is body temperature important? Well, fever is a really important way that humans try to defend themselves against viruses. Our bodies mount a fever in order to try and eliminate the virus. But bats and Ebola have been co-evolving for a long time. And because bats have this high body temperature for a lot of their life, the virus may have adapted to survive in these higher temperatures. So that when a human gets infected and gets an elevated temperature, a fever of 104 degrees, the virus doesn't care because it's used to hanging out in bats whose temperature is 104 degrees a lot of the time. So these are just some of the ideas that scientists have come up with to try and explain why bats are less susceptible to getting sick from Ebola than humans are. But unfortunately, not a lot of people actually study bats in labs. And when I looked online on some of the websites where I go to buy materials to study immunology, I didn't find any materials for studying bats. I saw some for mice and for humans and things that we typically study and think are important for human disease, but none for bats. And so I think one important and interesting question is how flight affects immune responses. Bats can fly, and they're the only mammals that can do so, and birds can also fly, and birds, as I mentioned a few slides ago about zoonosis, are also reservoirs for some really dangerous viruses. So maybe being able to fly has something to do with your immune response. A second open question is how are bat and human immune systems different? I mentioned that they're both mammals, and so we assume that they're the same, but it seems like there may be something that protects bats from some of these really dangerous viruses in humans. And then the last question is, what else about bats makes them good reservoirs for really dangerous viruses that are threats to public health? Understanding this and trying to maybe control viruses in bats is a really important goal for public health and control of some of these epidemics. So with that, I'll turn it over to Kyla, who's going to talk a little bit more about public health and the Ebola outbreak.
So I'm going to kind of change gears from the basic science that Zuri presented, although it does relate because this particular Ebola outbreak was really started by what scientists believe an initial transmission from a bat to a human child. But I'm going to tell you a little bit more about this Ebola outbreak from a public health perspective and what people did in order to identify the transmission and quarantine and just overall the entire public health response. But in order to do that, we need to understand where we are in the world. So, the first case of Ebola, what is known as the index case or patient 0, occurred in West Africa. So if you look at the continent of Africa, just in case you don't know, it occurred in this village called Meliandou, Guinea. And so you can see Guinea right here on the coast of Western Africa. And if we zoom in a little, you can actually see the village. It's fairly pretty close to the coast in the very western part of Guinea. And if you look more into some of the pictures that have come out from the epidemiologists, which are just the scientists that study, transmission of diseases, you can see actually pictures of this city. So up here is a picture of Meliandou. It's composed of around 31 houses. It's very difficult to get to. It's about 2 hours on a pretty horrible road by car to get to the next village. And the very first case of Ebola was identified here. And so it was a 2-year-old boy. He lived in this house, which you can see in red, and not too far away from the house was this tree, which you can see here on the bottom. And inside this hollow tree, there was a colony of bats. And in talking to various people in the village, including the village chief, the epidemiologist discovered that that the local children loved to play in this tree. I mean, you can imagine how much fun that is as a child, just to have this huge hollow tree you could play in. And they weren't really concerned about the family of bats living there because bats are a big part of the culture. The people hunt bats, they eat bats, there are many children's games around bats. And so no one really was concerned about the children playing in this hollow tree. And so the 2-year-old boy, it's likely they think that the first Ebola bat to human transmission occurred in this tree. But how did it go from one 2-year-old boy to the outbreak that's killed thousands of people? And so although this might be a little hard to see, you can see that after the 2-year-old boy got sick, the next people who got sick were the caretakers. This became his mother, his sister, and his grandmother. And all of them passed away in December 2013. But whenever the grandmother passed away, there was a huge funeral, and many people from various villages around the area actually came to this funeral. And when they did, they participated in various burial rituals that are traditional to this area. This includes washing the body, kissing the body, touching the body. And if you've been aware of any kind of news reports about Ebola, this is exactly how it's transmitted. And so after these people came and paid their respects to this, well-respected grandmother, they then carried the virus back to their own villages, and then it immediately spread. So over the course of a few months, pretty much from December 2013 to March 23rd, 2014, which is when the World Health Organization first became aware and made the first announcement that there was an Ebola outbreak in West Africa, there had already been 59 deaths, or 56 deaths and 89 suspected cases. So this had already spread before the first public health officials had even stepped foot on the ground. And this is part of the reason why this outbreak became so bad. But let's switch gears and stop thinking about the whole picture and really zoom in on one person. How is Ebola transmitted from person to person? And in the news, I'm sure you're aware, it's transmitted through bodily fluids, things like blood, sweat, urine, vomit, feces. And these things are very prominent in Ebola symptoms. But I heard this question a lot, not only in news articles, but from people just talking about the outbreak. And the question is, well, if it's only transmitted through bodily fluids, then why do healthcare workers need to wear entire bodysuits? Why do the tips of their toes need to be covered if it's only transmitted through blood or vomit? And this has to do something with called droplet transmission. And this looks very similar to airborne, which is why I feel like there was a lot of confusion, but it actually is very different. And so when we sneeze or cough or even talk, there are these droplets that come out of our mouth, and most of the time we don't see them, but they come out anyways. And so there's really 2 types of these droplets. There are bigger droplets and smaller droplets. And so the bigger droplets are what Ebola likes to be in. It actually can't survive in the smaller ones. And that's kind of good news for us because when Ebola is in these bigger droplets, these droplets, gravity acts on them. And so they fall to the ground within 1 second. And so that even with the most violent sneeze, if I were to have Ebola, I would have a very violent sneeze and I would only be able to transmit the virus up to 3 feet. So if I had Ebola and I was giving this talk, it would be very unlikely that any of you would become infected with where you're sitting now. And this is very different from something that's transmitted through the air. And an example of this that's also in the news right now is measles. Measles is an airborne virus. And so measles actually can survive in the smaller droplets. And so within the 1 second after they come out of your mouth or nose, they are actually so small that they evaporate. And so then they can float through the air fairly quickly. And I kind of like to imagine this of, if you're vacuuming and you see the sunlight come through, you see these dust particles, and this is essentially what it is. And where Ebola can only be transmitted up to 3 feet because gravity acts on it, measles can actually be transmitted up to 30. So if I were infected with measles right now and giving this talk and none of you were vaccinated, it would be highly likely that every single one of you would be exposed to the virus before the end of the talk. And so this is what makes measles actually in the scientific world considered a much more dangerous virus than Ebola. And we can quantify this through something called the R-naught number. And so this is just a statistical test that people like to use because it's jargony. But essentially what it means is that for every person who's infected, how many people will they infect? And so for Ebola, this is it has an R-naught number of 2. So if I had Ebola, I would likely infect 2 other people. And these are usually healthcare workers, people who are in very close contact for a very long time with the blood, vomit, and urine of an infected person. However, this is very different if we look at something like measles, which is airborne. So if I were infected with measles, I would likely infect 18 other people, which is a huge difference, and you can imagine how much easier something like measles can spread compared to Ebola. But back to the Ebola, mainly to the Ebola outbreak, once an outbreak of a virus or really any disease has occurred, what are the steps that public health officials take to stop it? And so the first thing they do is this term called contact tracing. And essentially what this is they talk to somebody who's been infected with Ebola. Ideally, you get the very first person. This obviously didn't happen in this case, but if you can, that's the ideal situation. And you talk to them and you say, ask them every single person, everywhere they went. You learn everything about their life that they have come in contact with over the course of the incubation period, which Zuri mentioned in her talk, and for Ebola is 21 days. If you're not exhibiting symptoms by 21 days, it's likely you don't have the virus. And so they talk to every person. So this can be a lot of people if you imagine how many people you interact with on a daily basis. People at school or at work or at the mall or on an airplane. The number of people that you have to talk to do effective contact tracing can be very large. And so once you get a list of people that as one sick person has come in contact with, you have to contact them. And then you test them, and usually the test for Ebola was checking their fever multiple times a day, or checking their temperature multiple times a day for development of a fever. And if any of them develop a fever, then you immediately quarantine them. And we know that if, we are very effective in this contact tracing, if you get 100% of the people that are showing symptoms of Ebola into quarantine, then you can effectively stop the virus within the incubation period. However, this didn't happen in this outbreak, and you can imagine why. Just because the resources it takes to really stop an outbreak effectively is a lot of resources. And so places in the West, or these 3 West African countries that got hit the worst with Ebola just did not have these resources. So for healthcare infrastructure, for example, in the United States, we have about 98 nurses for every 10,000 people. In places like Liberia, they have 3 nurses for every 10,000 people. And this is a country of 4.2 million people, and they had 51 doctors before the Ebola outbreak. I mean, there just weren't enough people to actually do effective contact tracing. And then even if they did do effective contact tracing and get people who were sick with Ebola, in the middle of September, they had about a 1,500 bed shortage, which meant that 1,500 people who were showing symptoms of Ebola were turned away, told to go home, told to sit outside. I mean, there was nothing they could do for them. And this is an extremely horrible situation in order to, create a big outbreak. But another thing that I feel like wasn't talked about as much is something as simple as trust in government. So, whereas about 90% of the United States population actually trusts the government to do a fairly decent job when it comes to some sort of public emergency. This is not the case in the 3 West African countries that were hit the hardest, where only about 10% trust their government. And this has to do with the fact that civil war in all 3 of these countries has ended within the past 15 years. So if you can imagine that situation where public health officials are showing up to your door with a soldier in tow, asking to remove your mother or your sister or your daughter to a quarantine center where you would likely never see them again, you can imagine how hesitant you would be. I would be extremely hesitant to do that. And people in these countries were, lying in order to keep their family members with them. They were not allowing public health officials to come into their village. And this really exacerbated the outbreak in these West African countries. However, it's not all doomsday. Nigeria is a great example of how they effectively stopped this outbreak. So what happened was there was one man who flew from Liberia, I believe, to Nigeria, and they landed in Lagos, which is a population of 20 million people. And airport officials and public health officials immediately recognized the symptoms. He was quarantined. They did effective contact tracing, which involved contacting 900 people and making 19,000 face-to-face visits with these people, and they were considered Ebola-free in October of 2014. So, even in resource-poor settings, this can actually be done very effectively if we put into place the measures we know to work in a very effective and quick manner. So, we've already talked about this a little bit, but I really want to highlight why this was the worst Ebola outbreak. I mean, there have been Ebola outbreaks before, and typically they're sort of isolated to smaller villages. I think the highest death toll before now was 300. So why was this so bad? Well, first, normally, Ebola outbreaks remain isolated within small villages, and this was not the case. This quickly spread to very highly populated cities, really before public health officials could get it under control. Another thing is that there were no previous Ebola outbreaks in these countries. When the first symptoms started showing up, no one thought it was Ebola because Ebola wasn't there. And they thought it was malaria or Lassa fever or some other type of virus. And so they just did not have the resources in order to even be able to begin to diagnose these cases. And finally, the late time to first diagnosis really effectively stopped any sort of 100% or effective contact tracing before even public health workers put their first feet on the ground. And so this made it to the worst Ebola outbreak the world has ever seen. But where are we now? I mean, the media isn't really reporting on Ebola anymore. So far there have been 23,000 cases, around 9,300 deaths, and there's currently around 100 new cases a week, which sounds like a lot, but in the height of the Ebola outbreak, it was about 300 per country per week. So this is much less than it was. So scientists do currently believe it's slowing down, although it's probably going to take us still a while before we declare, these countries Ebola-free. But there's an aspect of public health that people didn't really talk about or even think about when the news was reporting about Ebola. And the fact is that Ebola wasn't even the highest killer in these countries, even during the height of the outbreak. So it might be hard to see, but this smaller bar down here is the number of Ebola deaths as of August 2014, where this higher bar up here is the number of deaths related to malaria in the same time period. So although we were very concerned about Ebola, there were thousands of more people dying of malaria in these countries during the same time period. And I'm not to say that, Ebola isn't a virus that, we should be very concerned about, because we should. I mean, it's a dangerous virus. But there are so many other public health aspects that encompass this entire outbreak. And the fact is that every bed in these countries was being used to treat Ebola, which meant that people with malaria, people with diarrhea, people with HIV, people with cancer or even kidney disease effectively stopped receiving treatment immediately and haven't been receiving treatment throughout the entire Ebola outbreak. So although the deaths of Ebola were 9,000, the death toll is actually much higher due to other diseases. And the infrastructure they're going to need in order to repair and recover from all of these deaths and diseases is going to be a lot. So really the Ebola fight and the Ebola public health crisis is just beginning because the virus is slowing down. the media was very much, doomsday in America, we're all going to get Ebola and die, and was this ever really likely? And so we know that the R0 number is 2. It's not a super infectious virus. We had very effective contact tracing, although there were a couple blunders at the beginning. We have a very strong infrastructure. We have the people in order to do the contact tracing. Typically, we trust our government in order to do effective contact tracing. We're not going to be concerned if, somebody tries to quarantine somebody of what the true purpose is. We had protocols and policies in place for outbreaks of this type, so it was really very unlikely for Ebola to ever become a doomsday situation in the United States. And with that, I'm going to pass it off to Caroline, who's going to talk a little bit more about the social impact of Ebola.
Thank you so much. Thanks for coming out, everybody. The title of my talk is The Disease Goes Viral, Press, Politics, and Public Safety. I want to start by saying I have a little bit of a confession to make, and that's that I'm actually not a scientist. I'm a historian. So that means when I study a disease, I'm really not qualified to talk about, say, how it infects someone's body and what kind of a reaction they might have to it, like vomiting or a rash or something like that. Instead, what I am qualified to study is how a disease infects a society and what kind of a reaction a society might have to it, like when the media vomits out information and creates a rash of panic across the country. So tonight I'm going to be talking about Ebola in the US media, and because I'm a historian and I kind of can't help myself, I'm going to have a few historical examples along the way that hopefully we can learn from. Okay. So the first thing I wanted to just take some time to establish tonight is just how incredibly low the number of cases in the US actually was. So I decided to create this chart comparing the number of global cases and deaths from Ebola compared to the number of US cases and deaths. So as you can see here, this information is a little bit out of date. It's from January. It's a little bit higher now. But there have been over 20,000 global cases of Ebola, and at this point now more than 9,000 deaths. The number in the US is so small, I couldn't even make the bars show up on the chart. That's 4 US cases diagnosed here and only 1 death. So the numbers have been very small. We should be thankful for that. But compare that to the kind of media attention that Ebola has been getting in the US media, and it's a pretty drastic difference. So this is a graph that shows the number of news stories about Ebola reported from different regions around the world. So here we can see that kind of in the summer days of the outbreak and even into the early fall in July and August, the yellow line is pretty dominant. And the yellow line is stories coming from reporters in Africa. And that makes a lot of sense because that's obviously where most of the Ebola cases were concentrated. But then on September 30th, we see this big jump in the orange line, and that's the number coming from reporters in the United States. And that was the day when the first individual with Ebola was diagnosed here in the US. So big jump in media attention. And that continued to rise pretty much exponentially into October, well outstripping the African numbers. So very interesting when you compare it to the number of cases. When there's this much media attention on an issue, it's obviously important for us to pay attention. Not just because the issue itself is, evidently somewhat interesting for global affairs, but also because it's going to tell us a lot about our society, about our priorities and our values, about how we consume information and how we use it to make decisions. This relates to a term that I want to introduce tonight that I think will help us talk a little bit more about Ebola in the media, and that's emotional epidemiology. So Kyla introduced us to the term epidemiology, which basically is used, doctors, public health officials, that kind of thing, to talk about their work to trace how a disease moves through a society. So how it spreads, who gets it, why they get it, how to control its spread, that kind of thing. Emotional epidemiology is a little bit different. Instead of tracing how a disease moves through a society, it traces how ideas about a disease move through society. So in the case of Ebola, it's going to be largely a matter of tracking things like fear and panic and distrust, and the media obviously had a pretty big role to play in that. So one of the first things that I noticed about the emotional epidemiology of Ebola, particularly in the US media, is how they use science. One of the first lessons that you learn when you're a historian of science and medicine is that science is kind of just one possible way of understanding the world. So if we lived in a different time or a different place, or we belonged to a different culture, we might look to like the stars or the spirits or something like that to tell us what a disease is, how it's spread, how to get rid of it, that kind of thing. But our society puts a premium on science. It's how we understand things to be true, factual, correct, that kind of thing. I'm pretty grateful for the most part that we do, because science has obviously given us a lot of insight into a lot of things and made our lives a lot easier and a lot healthier. But what's interesting is that the media also know the value that we place on science. So this is a screenshot from CNN. You can see here that they've used an image of an Ebola virus, but they haven't actually explained anything about it. They've also got this lovely stock photo, maybe, not really clear, of some kind of test tubes from some kind of lab. I mean, maybe they have to do with Ebola, maybe they don't. Journalists aren't scientists, but what you can see from something like this is that the media knows that if they can use science, they can make themselves look credible, whether they deserve it or not. And let's face it, they don't always deserve it. As we learned from the earlier talk, Ebola is transmitted through droplets, which means it would have to undergo some extremely unlikely, like nearly, I won't say impossible, but nearly impossible mutations in order to become airborne. But you wouldn't know it from a headline like this one from CNN, Ebola in the air, a nightmare that could happen. This is focusing a lot more on doomsday scenarios than on the actual facts about Ebola. Here's another article. This is an op-ed from the New York Times, What We're Afraid to Say About Ebola. Pretty sensational title, and the text is even more sensational. It actually goes on to compare Ebola to the plague, which in its time killed about 40% of the European population. That's pretty extreme stuff. Even though this is written by a member of the scientific community, what the article doesn't bother to tell you is that he's considered a very extreme member of the community. So the vast majority of his colleagues totally disagree with his projections about the virus mutating and causing these really catastrophic death rates. They give him this op-ed, he gets this prominent article, largely because what he has to say is sensational. They know it's going to get attention. And in other articles, he was actually quoted alongside his colleagues as if their views were equally popular in the expert community. And this just really wasn't the case. It's actually what people in media studies call false balance. So giving the impression that there are two equal sides to a debate, when in fact people in the expert community, are very much falling on one side rather than the other. We also saw cases of people getting sent home from school, taking paid days off work, teams in hazmat suits being mobilized, just because of rumors or fears about Ebola. Obviously, when it comes to a serious disease, it is important for us to be really cautious, but this kind of thing can also be very expensive and very disruptive to a society. So we want to make sure that we're not letting bad reporting and kind of anxiety fueled by the media make these sorts of decisions for us. The Washington Post newspaper was actually really curious about this relationship between media and anxiety and decision making. So they did a study a few years ago to kind of test out this issue. So what they did was they asked people to read an article about a fictional smallpox outbreak, but it looked really authoritative. It was about an outbreak in Cleveland, and all these people were apparently sick. So if you're reading this, you would probably believe that it was true. Then they asked them to rate their anxiety levels. They found, which makes sense, that people who read the story reported higher levels of anxiety. I'd probably be pretty anxious too if I read a fairly authoritative-looking article about a smallpox outbreak. And then they asked these people who'd read this article with this, and developed this higher level of anxiety what they thought about different emergency powers that a government might put in to control the spread of a disease. And they found that people who'd read this article and reported this higher anxiety were much more likely to support things like mandatory medical examinations, quarantine, or even destroying sick people's property. These sorts of extreme safety measures can definitely be constitutional and legal in the right circumstances. But anytime we're making a decision that might be restricting someone's personal liberties, we have to be making a very careful calculation. We definitely can't let anxiety fueled by the media make those sorts of decisions for us. We also saw a lot of this kind of talk in the pleas by some politicians to have a travel ban in the case of Ebola. So that's basically prohibiting people who'd been in certain West African countries from coming into the United States. And the authorities, in the end, had to weigh a lot of really complicated factors to make this decision. And they concluded that a travel ban really was not a good idea because it would probably encourage people to lie about where they'd been, for example, or their medical history. People might find just other sneakier ways to get into the country that are much harder to track, and it would make it more difficult for aid workers to get to and from places where people needed help. But that decision had to be made on the basis of science and fact, and not the kind of fear that the media was encouraging. This question of how to weigh personal liberty against public safety is actually a really old one in the history of medicine. Has anybody here heard of Typhoid Mary? Does that ring any bells? Okay, well, Mary Mallon, Typhoid Mary, was actually a real person. She was a cook who worked for wealthy New York families in the early 20th century when they mysteriously started getting sick with typhoid. Typhoid is a really nasty bacterial infection. It causes all sorts of horrible symptoms like high fever, weakness, rash. It can cause liver problems, horrible diarrhea, and in some people eventually death, so very unpleasant. Mary eventually infected over 50 people, and actually 3 of those people died. But she was what they call a healthy carrier, so she didn't think that she had anything wrong with her. She felt fine, but she was breeding this typhoid bacteria essentially in her system, and she could spread it to people if she didn't, say, wash her hands after using the washroom. So the investigation eventually traced back to her, and she was quarantined for 23 years on North Brother Island, which is a small island in the East River, kind of just north of LaGuardia Airport, sort of northwest of there. You can actually still go by it on boats today, even though it's all kind of decommissioned. You're not allowed to visit anymore because it's got these old ruins and everything, but really interesting. But yeah, she basically lived out the rest of her life on North Brother Island and died there. So yeah, quite unfortunate. But one of the things that historians have really noticed is that part of the reason that the government was able to take such extreme measures with Mary was because of the media. So the early 20th century was the peak of what historians call yellow journalism. So this is actually a really great example. Yellow journalism uses bold headlines, dramatic illustrations, usually pretty not so good reporting, and a lot of sensation to sell papers. The term yellow journalism actually refers to the yellow-colored ink that they would use to sort of highlight the headlines and draw more attention to them and get people to buy the newspapers. And Mary was at the heart of some pretty serious yellow journalism in the early 20th century. So this is an image from the New York American from 1909, and it shows an image of Mary throwing skulls into a frying pan, almost as if they're eggs, like she's kind of cracking them into the frying pan, cooking up death. So, I mean, this is some pretty extreme stuff here. There's still a lot of debate among historians over whether quarantining Mary for so long was the right thing to do, but what we can say for sure is that the media had a lot of influence over the public's opinion, and in many ways things have really only gotten worse. It's true that Ebola can be really dangerous. I mean, as Zuri mentioned, if it's totally untreated, it can have a death rate as high as 90%. So obviously, it is something we want to be careful with, especially if you're, for example, a healthcare worker dealing with sick people, maybe being vomited on and that sort of thing. Obviously, you want to be really cautious. But part of the reason that we're so concerned about Ebola and that the media has jumped on this story is kind of because it's an unknown entity for most of us. I mean, 30,000 Americans die of the flu every year, but most of us don't really worry that much about the flu. A lot of us even forget to get our flu shots every year. I know I've definitely been guilty of that, I have to say, in the past. But that's because most of us have had the flu, or we know someone who's had the flu. We don't really worry about it. We kind of expect that if we get it, we know it'll happen, and we don't really think too much about it. But we don't have the same kind of personal experience with Ebola, and so we can be made to feel very fearful about it when we hear about these drastic reports, especially coming out of presumably reputable magazines like this one out of New York with Ebola is coming. It looks almost like it's written in blood. I mean, this is really dramatic stuff. A lot of people actually said they hadn't seen this much panic in the media since the AIDS crisis of the 1980s. So this is a Newsweek article from 1983. It has the word epidemic in big letters. It actually refers to it as possibly the public health threat of the century. So again, we see really extreme language. But the situation, to be fair, was actually really different with AIDS. At this point in 1983, they didn't even have a candidate for the HIV virus to link up with AIDS. That wouldn't come until about a month after this was published. So they really didn't know what was going on. And in fact, a lot more Americans were sick. What's different with Ebola, fortunately, is that we just know so much more about the virus. We know what it looks like, we know how it's spread, we know how to contain it for the most part, and that's really something we should be happy about. But it also makes articles like this one, "You are not nearly scared enough about Ebola," all the more ridiculous. I have to say, I mean, there has been a lot of really great journalism with Ebola. There have been a lot of really responsible reporters who've really gone the distance to make sure that they're reporting on science accurately and truthfully. But we also see things like this. This is from Foreign Policy, which is normally considered a fairly reputable news source. But the subtitle is really interesting. If Ebola hits Lagos, we're in real trouble. Well, as we heard from Kyla's talk, Ebola actually did hit Lagos. It hit it about a couple weeks before this was published. But thanks to a really quick response from the Nigerian government, they were able to contain it, and only 20 people in Nigeria actually got Ebola. The country was declared Ebola-free in October. So this is really a great example of the kind of irresponsible reporting that we saw, and we should really, in some ways, know better. So what is the solution to all of this? I mean, how do we control the media that are not only wrong, but also sometimes destructively wrong, causing people to stay home from school, stay home from work, cash in their airline stocks, call the medics at the least sign of trouble? How do we control this? Well, we can say that censorship is definitely not the solution. I can tell you that. The Spanish flu actually offered a really good test case for this. So the Spanish flu first emerged just at the end of the First World War. So this was a period when actually the media were still under really strict government control in most countries that were involved in the war. They didn't want to publish anything that would lower morale. And so actually the reason that the Spanish flu is called the Spanish flu is not because it emerged in Spain, but because Spain was a neutral country. So it was one of the only places where actually accurate information about the spread of the disease was emerging. So we have an article here about the Spanish epidemic, for example, from June 1918. And in the other countries in Europe, for example, and in the United States, the media were kind of acting like nothing was wrong. A lot of public health officials also were acting like nothing was wrong. And this was really disastrous. It really allowed the disease to spread further and faster, and people lost a lot of trust in their public health officials. So we definitely don't want that to happen. So we're left with, the same question. What is the solution? Well, it turns out, in some ways, the answer is right in front of us. This is a screenshot from Anderson Cooper's show from October 14th, talking about whether the US is prepared for Ebola. In the hands of the media, a story like this is actually a little bit like a virus itself. It's only successful if it can multiply and become contagious, and the easiest way to do that is through fear and attention-grabbing headlines like this one. But if a virus is too powerful, it'll kill its host, and then it's not a good virus anymore because it can't spread as easily. The same thing is kind of true of the media. They don't want to take things too far. In fact, a lot of people were already getting really frustrated with the kind of doom and gloom of Ebola and all these dire predictions that just weren't coming true. So in order to preserve its credibility, the media made itself the story. Here's less than a week later, October 20th, another article from CNN, again featuring Anderson Cooper, but this time the headline is really different. Ebola hysteria, an epic epidemic overreaction. My favorite part is actually here. The first line of the article is, "This is getting ridiculous." Well, that's irony for you, since they were in a large part responsible for all of this media hysteria in the first place. But this is, I think, one of the best lessons that we can learn from Ebola in the media in America, and it's that by continuing to be skeptical about how they report things, how they use and abuse science, and holding them accountable, we can make sure that this sort of fear-mongering doesn't become the whole story of Ebola in America, and that we can go back to making sure that people who need help actually get it. Thank you very much.